Today we're going to talk about the kilowatt hour, okay, and what it means, why it's useful, and basically what it's a unit for, okay. Now, first of all, to do this, we need to remind ourselves about a key equation, okay, and that is this one here, okay. Energy equals power times by time. Now, we will have normally seen this, and the units we would normally use would be the following. We would use energy measured in joules, power measured in watts, and time measured in seconds. And that is absolutely fine to normally use that, okay? If I had something, for example, that was 50 watts, a 50 watt light bulb, for example, and I used it for 3 seconds, then the energy, would equal 150 joules. Nice and easy. Now, the problem with this is that the joule itself is not actually, it's not a very useful unit for day-to-day things that you're going to be doing, okay? Things that you're using in your house, like an oven, for example, is going to use a lot of joules, okay? The joule is such a small unit. Now, just like in speed, we have different units for speed. The standard unit for speed is meters per second, but the one you use day to day is miles per hour, or maybe kilometers per hour, depending on where you are. Okay, there's different units that can mean very similar things, but they have different amounts. 1 mile per hour is not the same as 1 meter per second. Okay, it's if you're Usain Bolt and you run at 10 meters per second, this is actually somewhere between 20 and 30 miles per hour. Okay. So there's different units for different things, okay? If I said to you, how far is it from Birmingham to London, you're not going to give me an answer in meters, okay? It's unlikely you would anyway, okay? You're likely to give me an answer in miles, okay? Because a mile is a much more appropriate unit for that kind of distance. And the kilowatt hour is actually a unit of energy that's much more appropriate for the things that are going on in our day-to-day lives, and it's the one that you actually get charged in when you're using energy in terms of electricity or gas in your house. So let's look at what it actually means. Now, I'm going to leave this equation here, okay? We've seen that if we multiply a power in watts by a time in seconds, you will get your energy in joules. Very, very straightforward. Instead of that, I'm going to use different units for these two things. If I said to you that let's use a realistic example here. Let's use a oven, okay? So if I had an oven and I put that oven on, I was cooking maybe the Christmas turkey or something, okay? It's something that's going to take a little bit of time. I don't actually know how long a turkey takes to cook, but an oven might have a power of 5 kilowatts, okay? And you might want to cook that for 4 hours, for example, okay? Now, instead of converting this into watts and the time into seconds like I would normally do to get it into my SI units, my standard units, I'm going to use the kilowatt hour, so I'm just going to use kilowatts, and I'm going to use 4 hours, and this gives me a energy of 20 kilowatt hours. It is as simple as that, okay? You make sure your power is in kilowatts, you make sure your time is in hours, and you're going to get an energy of 20 kilowatt hours, okay? Now, that means that if the energy company want to charge me, and again, you know, this varies, but if the energy company charged me, say, 25 pence per kilowatt hour, then I would work out how much that actually cost me, okay? So 25 times by 20 is going to give me so it's 4 and 5, so that is going to be £5 is going to be the total price there. I could do the same thing in joules, okay? So what I'm going to do this time is I am going to, and we'll use a different colour here, I'm going to use 5,000 watts, and I'm going to times that by the amount of seconds in 4 hours, which is 4 times by 3,600, and this is going to give us 5,000 times 4 times 3,600 is going to give us 72 million, okay? Okay, now 72 million joules is the same thing as 20 kilowatt hours. Just like you could say that approximately 3,200 meters would be about the same as 2 miles. It's the same amount of energy, it's just in a different unit. Now we can see 25 pence per kilowatt hour is a fairly sensible number. We can make sense of that. If someone said to you 25 pence per kilowatt hour and then another energy company said 22 pence per kilowatt hour, you would know which one very easily. They're sensible numbers, you'd be able to use them, okay? Now, if we wanted to work out how much it costs per joule of energy, we can use these numbers here. We knew this was the amount for 20 kilowatt hours. So if we said £5 divided by 72 million is going to give us, and I've just done this on my calculator, approximately 7 times by 10 to the minus 8, and that would be pounds per joule, okay, which is going to be 7 times by 10 to the minus 6 pence per joule, or you could write 0.000007 pence per joule. Now this is such a small number that it might seem cheap, but it's going to some people aren't really able to deal with these kind of numbers. So if we use this as a unit, okay, and we use a sensible amount of money per kilowatt hour and a sensible amount of kilowatt hours for a day-to-day thing, rather than a ridiculously small amount of money per joule and a ridiculously large amount of joules, you're going to be able to, the general public are going to be able to understand how much energy they're using a lot better, okay? And it's as simple as that. That's all a kilowatt hour is. Okay, so here is an example question where we're going to have to do some conversions, okay, from the normal units that we might use to into our units for kilowatt hours. How much would it cost to boil a kettle if the power was 2,000 watts, it took 3 minutes, and the price was 28 pence per kilowatt hour? So let's look at this. I want to work out how much energy I'm going to be using. So I'm going to say energy equals power times by time. Now my power is going to be 2,000 watts, but I need to put that into kilowatts, okay? So 2 kilowatts times by, now my time I've given is 3 minutes. Now normally I would turn that into seconds. I would be using time in seconds as 180 seconds, but I want to use it in hours. So my 3 minutes in hours, okay, you're going to do 3 divided by 60, okay, which is obviously 1 over 20. So 3 divided by 60, 1 over 20 is going to give you your 0.05 hours, okay? So 2 kilowatts times by 0.05 hours, you can times 2 by 0.05, it's as simple as that, is going to give me 0.1 kilowatt hours, okay? And I said that the cost is 28 pence per kilowatt hour, so my cost is 28 pence per kilowatt hour times by my amount of energy, which is 0.1 kilowatt hours, which is going to cost me 2.8 pence. Okay, so it's as simple as that. Okay, the final thing with kilowatt hours is just to think how big is actually 1 kilowatt hour in joules. Okay, and it's very, very straightforward. We can just say that, again, we're going to say the energy is the power times by the time. Now, if I have 1 kilowatt of power and I times it by 1 hour of time, I am going to get 1 kilowatt hour of energy. Now, let's just look at that in joules then. So if I was to say that I had 1,000 watts, is exactly the same thing, multiplied by 3,600 seconds, which is the exact same thing again, we will get 3,600,000 joules. And that is the amount of energy in 1 kilowatt hour if you express it in joules. Okay?